so we just covered this multiplication when we had a binomial times a trinomial, but most of the time when we did those, we ended up with something that had like 4 terms or something in it. It ended up being really big, but in this case, after we simplify it, it simplifies down to something very simple, only 2 terms, because all those terms in the middle canceled out. This is a special case that we're going to look at factoring today. This is what we call, this specifically is the difference of perfect cubes. Okay, we've done the difference of perfect squares, but this is the difference of perfect cubes. And then the second example, binomial times a binomial, we're used to that, but we're used to most of the time it ends up being a quadratic trinomial. Okay, the highest power is x squared, and then we only have 3 terms. But in this case, because the first one had x squared and the second one only had x, we didn't end up with any like terms, so we couldn't combine anything. We ended up with this cubic 4-termed polynomial. We're going to look at how to factor that. We'll look at that tomorrow. But today we're going to tackle the perfect cubes. So that's what we're going to start with. But with perfect cubes, with perfect squares, we could only do it if it was the difference. With perfect cubes, we can do the sum and the difference because of some properties of cubing numbers. Squaring numbers, you can only take the square root of a positive number. You can take the cube root of positive and negative numbers. So we can do the sum and difference of perfect cubes. So I gave you kind of an outline here of the steps. If we're factoring these, like always, we always start by looking for a GCF. You always want to check and see if there's a GCF first before you jump into the process. If we don't have a GCF, then instead of setting up 2 sets of parentheses with 2 terms each, we've got 2 sets of parentheses, but one is binomial, 2 terms. The second one is a trinomial. We need space for 3 terms to go in the second set of parentheses. Okay? We're going to find the cube root of each term. I do have a list of perfect cubes up here in front of the board. I cannot leave that up during the final exam, so if you don't kind of learn what your perfect cubes are, let me show you where it is on the calculator. If you go to math, option number 4 is the cubed root. Okay, option number 4 is the cube root, so you can find out if any number there is a perfect cube. Okay, so there it is on the calculator. We're going to put those 2 terms in the first set of parentheses. So after we take the cube roots, we put those in order in the first set of parentheses. The second set of parentheses is built from what we have in the first set of parentheses. So step 4 says we square the first term of the first set, and that goes in the first blank in the second set of parentheses. Okay, this is going to be a whole lot of words, but you'll see here in a second. I would actually like to switch the order of steps 5 and 6. Okay, I would like to switch the order of steps 5 and 6. You can put little arrows there on your paper if you're looking back at it, just so we can do the second set of parentheses in order. Okay, so we've got the first blank filled in. The second blank comes from multiplying the 2 numbers in the first set of parentheses. That goes in the second blank, and then the third blank, we square the second number. Okay, sounds like a whole lot of stuff, but it's really not that bad once you get into the swing of doing it. And then I never put any signs, any pluses or minuses in there until the very, very end, and I assign those same, opposite, always positive. Okay, same, opposite, always positive. So I'll show you that here in just a second. Are you ready to take your test? Okay.